Here is section 5.1, exercise 84. Here we're asked to find extrema, relative extrema, points of inflection, that sort of thing. And we're told that y is equal to x squared log x over 4. Now, again, I might use the properties of logarithms to write this as x squared times the log of x minus the log of 4. And so I could write this as natural log of 4 times x squared, and then minus x squared log x. And so now when I take that derivative, I have 2x here times the log of 4. That probably looks better if we write it as 2x log 4, I suppose. And then minus, now here I have a product rule, so I need the derivative of 2x, the derivative of x squared, which is 2x times log of x, and then plus the x squared times 1 over x. And so now this is just an x here, so I have an x there and an x here. So in terms of x, that's a minus. So I have 2 log 4 minus 1 all times x, and then minus 2x log x. And okay, so we have that. That's y prime, and we could ask, well, where is that thing equal to 0? So this is looking pretty ugly. So as I look at something like this, this is, I know I need to set this thing equal to 0. I guess I do have, right? I've got an x there and an x there. So one possibility you might think would be x equals 0. Well, that is a critical number, x equals 0, when I pull that out. So x times, and then what I have left is this 2 log 4 minus 1 and a minus 2 log x. And so I have that equals 0. Well, so I could let x equal 0. Now, y isn't even defined at x equals 0 because I can't take the log of 0. So that is a critical number. Okay, so x equals 0 is a critical number, but the function's not even defined there. So that's definitely not a relative extrema. It could be where an asymptote lives or something like that. But I can look for something here, and so what I have is that minus 2 log x is equal to 1 minus 2 natural log of 4. So log of x is equal to, I've got a minus there, so I'll turn that around, make that 2 natural log of 4 minus 1 over 2. And so x is equal to e to that number, 2 log 4 minus 1 over 2. So there is a critical number, and of course the question is, well, is that a max or a min or what? I don't know. Let's take the second derivative, y double prime. Maybe that might help us. You never know. Y double prime of x equals, well, I suppose I'm going to use this form, and do a product rule. So doing that product rule, I take the derivative of x, which is 1, so I get my 2 log 4 minus 1 minus 2 log x. Boy, this is an ugly problem. And then plus x times the derivative of this thing. Well, there's a constant, so that's 0. And so we get x times negative 2 times 1 over x. Okay, so those cancel to be 1. Now, again, things are not defined at x equals 0, but, well, we've got a natural log here and so forth. So that was a minus 2. There's a minus 1. So it looks like y double prime is 2 natural log of 4 minus 3 minus 2 log x. Okay. Now, when could this be 0? That would be an inflection point. That would be at minus 2 natural log of x equals, again, we have the minus thing, but I'm just going to leave it as a minus 2 log 4 minus 3, because I'm going to divide by the negative 2. So we get log of x is equal to 2 log 4 minus 3 over 2. Wow. Okay. And so if I have done this correctly, x is equal to e to the 2 log 4 minus 3 over 2. Now, these numbers, can I do anything with them? Well, I could just put them into a calculator and get them done that way. There's a little bit more I could do with them, I suppose. Take this bottom number that we can get to. So this is e to the log 4 times e to the negative 3 halves. So that's just 4 e to the negative 3 halves. See, so that's not near as nasty a looking number as before. So 4e to the negative 3 halves. Up here, we could have done a similar thing. I guess this one, again, the 2's would cancel, so we would get 4e to the negative 1 half. Okay, so there's our critical numbers. 4e to the negative 1 half is our first order critical number, and here's our second order critical number. Now the question is, okay, can I take can I place that into the second derivative to determine positive or negative for y double prime? Whew, that's getting to be long, isn't it? Okay, so let me try y double prime of, was that 4e to the negative 1 half? And that is equal to, well, let's see. So I guess we had that. So that is, oh, this is actually going to be quite amazing, I think. So this is 2 log 4 minus 3 minus 2 natural log of 4 e to the negative 1 half. Okay, so that's 2 log 4 minus 3 minus 2 log 4 plus 2 log e to the negative 1 half. Okay, because we can split up that multiplication into a plus, and the 2 out in front has to go with both. But notice, oh, wow, amazing. So we get -3 and then minus, but look here, we've got log e to the -1/2. That's just -1/2. And so this is -2 times the -1/2. This is -3 plus 1. And so we get -2. So after all that, it looks like that. We have concave down. And so at x equal 4e to the -1/2, we have a relative maximum. Wow. Who'd have thunk it? And then the question here, now, is this an inflection point? Well, I can kind of check that by checking the first derivative, right? It's, it would be an inflection point if things were always increasing or always decreasing around it. And I'm guessing they are, but we had what, 4e to the -3/2. If we place that into y prime, wow. Okay, so I'm going to put it over here. This is getting messy. Y prime of 4e to the -3/2. That's where our possible inflection point is. Well, that's here. And again, the key is I'm going to get that 2 log 4 of all this. And so the x, right, is 4e to the -3/2. So I have that. So that's positive. And then this 2 log 4 is going to cancel out with that 2 log 4. And so I'll be left with a -1 and a -2 times -3/2. And so that is +3, +2. And so this thing's going to be greater than 0. So after all that, we have our relative max there, and here at this x value, we have an inflection point. Wow. Now, I suppose we ought to go check. So again, what the heck was our function after all that? X squared log x over 4. So let's try, that was interesting. It cleared itself. That's good. So what did I say? F of x, f of x is equal to, I think, what was it? X squared, I think. X squared times log, so I need functions here. Miscellaneous under there. Natural log of x divided by 4. And okay, go back and check that real quick. X squared, x over 4. Okay, and now we're going to look for relative max at whatever we said there. 4 to the -1/2. 4e to the -1/2. So, okay. So, cool. So after all that, it looks like I got a negative wrong. right? Because right there, let's check out that number, right? That's 2.426. Well, let's look at, what was it, 4, and then E, to the power negative 1/2, and that's 2.426. 2.426. Okay, so I had the right critical number, but it appears, right, that's concave up, that's a positive. I'm pretty sure I had found a negative, so let's see. So there's our number, and I did y double prime, and I have -3 and a +1. I had a -2. So I had a negative somewhere that went off. And so we're going to have to go find it. Oh, bummer. Okay, so I think we'll pause this for now and come back to trying to find that negative problem. Oh, and we should also look for our inflection point. Let's just check that out. So it looks like we have an inflection point in here somewhere. Now, what I could do is I could just plot f double prime of x, and so there is our point where it's 0, and that's 0.893. And so, of course, the question is, well, what's 4 e? Whoops, that's not what I want. 4e, there we go, to the -3/2. And you see we get our 0.893. So we found our numbers just dandy. However, notice, here the function's decreasing. I think I had it as increasing. And so I had a negative wrong somewhere. Bummer. Okay, and so I'm going to pause it for a moment, look for the negative, and tell you where that is. All right, it didn't take me long. There it is, right there. So I had x squared natural log of x minus log 4, and then when I rewrote it, somehow I switched the negatives. Bummer. So, everything would have worked out the same for the zeros. That's why we're okay there. But that was wrong. I should have had x squared log x minus 4 log 4 times x squared. And don't know, it happens. That's a nice thing with the technology to check the work. So I should have had that, which then when I evaluated all of these, I would have gotten, again, instead of greater than 0, I should have gotten something that was negative here. It was decreasing at that inflection point. And down here, when I looked at the second derivative, I should have gotten a +2 instead of a -2, which would have been the concave up. So, definitely that happens. But the good part is trying to check it and figure out where you went wrong. All right, so that is a very long exercise 84.